Hello, here I'm going to talk about the objective for the resistance test. Resistance tests are conducted to measure how a model hull performs at different speed in the water. These tests measure the resistance or drag that works against the model's forward motion. They involve measuring the model's resistance and speed in the water, along with its position. These tests are done in two conditions. The first one is model hull testing without extra parts to determine the basic shape resistance coefficient. If any additional part is added, it must be clearly mentioned. For example, rudders are included if they act as extension of a skate or in specific scenario. The second one is model hull testing with added parts to calculate the increased resistance coefficient caused by this component. All fixed appendage except propulsor should be attached. Movable parts or control surfaces are not part of the standard test. If vehicles have minimal resistance, they are not added in the standard test. Instead, their resistance is estimated separately.
So let's begin to the procedure of this experiment. First of all, we take zero readings of all instruments before each run. We ensure a representative mean value. Then, we tow the model at speed matching foot numbers for the full scale sheet. The third, select the model speed and accelerate it carefully to minimize speed overshoot. Then we release the model when the selected speed is attained. Next, begin data execution after reaching a steady speed or continuously from zero readings. Derive mean value from section with steady speed considering unsteady oscillations. Next step, we estimate the frequency of oscillations, store maximum, minimum, mean, and standard deviation values for each run. Then we repeat the process at our other selected speeds, covering the required range with alternate speed runs. Last but not least, allow sufficient waiting time between consecutive runs for consistent conditions. Record waiting times dependent on test, facility geometry, model type, and speed.
We move to another slide, which is the theory of the experiment. The preliminary ship design step should have a strong overview among which ship design might be the ideal suitable for the intentional use. The movement of ship through the water usually required the expenditure of energy in order to overcome resistance, such as the force acting against movement. Because the resistance of a full-scale ship cannot be measured directly, so we use the model test. To gain the knowledge about the resistance of the ship on water. In calm water, the total resistance can be divided into three major components, which is frictional resistance, residual resistance, and air resistance. Frictional resistance is the most common type of resistance, with resistance which is referred to the energy loss caused by the wave formed by the vessel. And viscopressure resistance are the two types of residual resistance. Wave resistance refer to the energy loss caused by the wave created by the vessel. Based on the ITTC recommended procedure, ship models are made with special consideration devoted to model manufacturing tolerance, surface polish, the production of appendix, the size and placement of turbulence stimulation. The extrapolation method ITTC 1957 will be used to calculate the dimensionless coefficient such as resistance coefficient, frictional resistance, residual resistance, and others. The frictional resistance is one of the numerous components that make up the resistance test. The net force that opposes the motion of the ship is known as friction resistance, which is it causes by the friction of the water operating over the entire weighted surface of the hull. The weighted surface area of the hull, surface toughness, and water viscosity all influence the frictional resistance. The ITTC 1957 equation for determining RTM and RTS are as follows on the slide. As you can see on the slide, it is the list of the formula that we use in this experiment, which is the total resistance coefficient for the model and for the ship, and then the frictional resistance coefficient for the model and the ship, also the formula for the residuary resistance coefficient used for the calculation on this experiment. Continue to the expected result, which is our group is currently engaged in the experiment where we are performing calculation related to a ship. In this progress, we have made certain assumptions about the ship particular, which is include various characteristics and specification. Those assumptions serve as the foundation of our calculation. The scale of our assumption is set at plus minus 28.03. This means that we are considering a range or margin of error around the assumed value. The plus and minus symbol indicate that we are accounting for potential variation or uncertainties in the ship's particular within this specific scale. So, in this table is our particular data, which is size for the ship is 30, model A107, draft for the ship is 1.7, while model is 0.06. Length of waterline for the ship is 55.73, which is for the model is 1.99. Next, for the weighted surface area for the ship is 744, and for the model is 0.949. And displacement for the ship is 940.97, while the model is 41.68. And the breadth for the ship is 12.5, and for the model is 0.45 meter square. By interpreting this scale, we aim to make our calculation more robust and adaptable to different scenario or potential changes in the ship characteristic. This approach allows us to provide a more comprehensive analysis that makes into account a reasonable range of value for the ship particular. And we can see in the slide, which is the calculation and the list for formula that we use to assumption the calculation by using the Freud's law to calculate the value of velocity for the model, and then for the value for RTM we get from the experiment, we get the data from the experiment, so we can get the value for RTM, CTM, REM. And also we use the same formula for the value for the ship, value velocity for the ship. Also we use the same formula as well. And yeah, that's it from our expected result. And the final is find the value of the power of the ship and the model. That's it from our group for this experiment. Thank you.